So we're going to start our next lesson on angle properties, but instead of being in triangles this time, we're going to work in polygons. So this is just a shape with multiple sides. I'll just kind of call it a closed shape with multiple sides. Now in this section, we primarily want to focus our energy on polygons that are convex. And a convex polygon means that every inside angle has to be less than 180 degrees. So for example, this one is not convex because that angle is way more than 180 degrees. So anytime you're thinking of 180 degrees, that's just a straight line. So if the angle looks like it's more than a straight line, then it's too big. So you can see here, this angle is smaller than a straight line. If I draw another straight line here, the next angle is smaller than a straight line and so forth. So we're only going to be dealing with convex shapes. Now we're also going to deal with shapes that are called regular. And a regular shape is usually one with equal sides, but we will get into that a little bit later. So before I go through the convex polygon kind of summary square here, what I want to do is kind of look at this little bit of an investigation. It says draw the polygons listed, a shape with more than one side. Create triangles to help you determine the measures of the inside angles. So we know that according to the triangle rule, every time I form a triangle, I know that when I have a triangle, the angles on the inside of the triangle, so this one, and this one, have to add up to 180 degrees. We don't know what each one is, but the total of them have to add up to 180 degrees. So when I look at a three-sided polygon, it's called a triangle. A four-sided polygon is called a quadrilateral. So in this four-sided polygon, I want to just start with one corner and form as many triangles as I can. So if I just create a line going down, I formed 2 triangles, and each triangle has 180 degrees. So this is going to be 180 times 2, which is 360 degrees. So in my shape, let's talk about this angle, this one, and this one all together should add up to 360 degrees. They're not saying that they all have to be the same, they just say the total of them have to add up to 360. Now at my next shape, I'm going to kind of fix a corner. I'm going to try to draw as many triangles as I can. So I connect there, I can connect there, but I can't really connect anywhere else. So I have 1, 2, 3 triangles formed in a pentagon, and a penta, kind of that abbreviation penta means 5, so our 5 gone. And so the total sum of the angle measures, the inside ones, is going to be 180 times 3 because there's 3 triangles there. And 180 times 3 is 540 degrees. So the sum of all the interior angles, the inside angles, have to add up to 540 degrees. So those 5 dots, those angles have to add up to 540. They don't need to all be the same. If we had a regular pentagon, a regular quadrilateral, a regular triangle, or equilateral triangle, those angles would be the same. Let's look at a hexagon. Now a hexagon has 6 sides, so I'm going to call it a 6-sided polygon. And I'm going to fix one of the corners. I'm going to draw as many triangles as I can. So 1, 2, 3 lines. So I form 4 triangles. And each triangle has to add up to 180. So 180 times 4 is 720 degrees. So the total of those inside interior angles is 720 degrees. So these 6 angles. Let's keep going. A heptagon, which is a 7-sided, so polygon or quadrilateral was a 4-sided. Quadrilateral. 3-sided was a triangle. 6-sided was a hexa. Hexa is a prefix for 6. 7-sided is a heptagon. So they may ask you in a question to take a heptagon. Instead of telling you it has 7 sides, you need to know that. I'm going to fix one of the corners. I'm going to draw as many triangles as I can from this one fixed point. So I formed 1, 2, 3, 4, 5 triangles, and 180 times 5 for each one of those triangles is 900 degrees. And lastly, the octagon. Now if we look here, I had a 3-sided polygon, and the number of triangles was 2 less. So I'm going to go -2. I had a 4-sided quadrilateral, and the number of triangles was 2 less. And if you notice, all of these show 2 less. So I would predict that this one would be a 6. We can just check it up. There's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6 triangles formed, and 180 times 6 is 1080 degrees. So it says, make a conjecture about the relationship between the sum of the measures of the interior angles S. So we're going to say S is the sum is going to equal, I took the number of triangles, and I multiplied it by 180. So my number of triangles, we said, was related to the number of sides, take away 2. So number of sides take away 2 times 180 degrees, and that gives us the sum of any sided polygon. So if we look at this little table above here, it'll summarize what we need. So the total sum of the interior angles, we're only dealing with convex polygons, is 180 times n minus 2. Now, if my polygon is a regular one, meaning that all the sides are the same, then each interior angle would have the same measure, and we just divide the total sum by the number of sides we have, and we will get the measure of each specific angle. And the sum of the measures of the exterior angles is 360. So let's look at some examples. So the first one, quite straightforward. I give you a 12-sided polygon, so my n is 12. I want each interior angle. They're talking about a regular polygon, so all the sides are the same. So the measure is going to be 180 times n minus 2. So that means 180, 12 minus 2 is 10. 180 times 10 is 1800 degrees. So all 12 angles have to add up to 1800 degrees. But since they're all in a regular polygon, I'm just going to divide by the 12 sides. 1800 divided by the 12 sides is 150 degrees per angle. So that's the measure of each angle. So I'm going to say each interior angle is 180 degrees. Now you're going to notice in my notes, the examples, they get trickier much quicker. We cannot forget about all our triangle rules we've learned, nor can we forget about all our line rules we've learned. So what we're going to do in this example, they say LMNOP is a regular pentagon, so the sides are the same. Pentagon means 5 sides. So my n is equal to 5. So if I needed to know the sum of all the interior angles, I could do 100 times n minus 2, which would be 180 times 5 minus 2, which is 180 times 3, which is 540 degrees. So all angle L, angle M, N, O, and P have to be 540 degrees total, but because it's a regular pentagon, if I divide by 5, I will get the angle measure per angle. So that tells me that this angle is 108 degrees. Angle M is 108 degrees. but you'll notice N is broken up into two parts. So we don't really know what angle L, O, and N are because they're broken up. But what we do know is if I take one of these triangles, and this is 108 degrees, and these two sides are the same, this is called an isosceles triangle. And in an isosceles triangle, if you have two sides the same, these two angles being formed will also be equal. So the angles in a triangle add up to 180. So if I take the difference between 180 and the angle that's left over, I get 72. But this 72 needs to be broken up into two equal parts. So if I do 72 divided by 2, I get 36, which means each of these angles have to be 36 in an isosceles triangle. So this angle has to be 36, 36. This one has to be 36 and 36. Now, we know that the total of angle O is 108 degrees. So if I minus the 36 degrees, I can get the leftover part, which is 72 degrees. So that's telling me that together angle O is 108, and they're broken up into two parts. They're broken up into the 36 and they're broken up into the 72. This one will be identical for the same reason. Now if I want to find the top angle, what I need to do is I know 72 plus 72 is 144. And in this triangle in pink, the angles have to add up to 180. So I'm going to call it the triangle rule. So if I do 180 minus 144, I get 36 degrees, which means that this remaining angle is 36 degrees. Now when I look at this, you'll notice that this side has to be equal to this side because they were formed from isosceles triangles, and that's kind of like the hypotenuse of the isosceles on both sides. So, and then these angles are the same, so we know that the triangle is isosceles, where two sides and two angles are the same. Determine the measure of OLN. So OLN is 36 degrees. So as long as you're showing your work, you don't need to format in a table format, but you need to justify each step and not make assumptions that a teacher would know what the heck you're doing. Now in the last example, we have a regular polygon with equal sides, and A, B, C, and D are in the regular polygon, or part of the regular polygon. What I want to do is I want to look here. So this, 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 and this is a six-sided shape. So it's six-sided, and it's regular because they're showing kind of that line indicating that all of these sides are equal. So we know it's a regular polygon. So if I do my 180 and minus 2, I get 180, 6 minus 2 is 4, 180 times 4 is 720 degrees. So all the angles in that yellow hexagon have to be 720. If I take that total and divide by 6, I get the measure per angle in that hexagon. So just like we did before, this would be 120. Angle C would be 120, so we can write that down. So angle C equals 120 degrees. This one is 120 degrees. This one is 120 degrees, but the last two are broken up into parts. Now we don't know if those parts are equal or not, but what I'm going to do is I'm going to come up and show you how potentially we can evaluate the rest of this problem. So if I were to draw an orange line here, I notice that this line where the orange line sits is parallel to this other blue line. So I'm going to kind of draw a Z rule going on. And in this Z rule, I know that whatever this angle is has to be the same as this angle. So what I'm going to do is I'm going to look at the dot plus 120 degrees. They lie on a straight line, equals 180 because of the straight line rule. So that means what number added to 120 gives me 180, which is 60 degrees. You can subtract 120 on both sides. So this angle is 60, which means this angle is 60 degrees. Now to find this angle, which I'm going to call P, I can do 60 plus P equals 120 because that's what we got for the measure of each angle. So P has to be 60 degrees. And then again, if I do the same thing over here, that angle has to be the same as angle D. And this one is 60 because of the straight line rule, so angle D has to be 60 degrees as well. And we can call that the Z rule. And then this part was the Z rule as well. We kind of did a mix of both to get that. So we got angle D and we got angle C. Now we need angle B and A. So what I'm going to do is I'm going to form a straight line here. So angle A plus 120 degrees has to be 180 degrees because of the straight line rule, if this lies on a straight line. So we know that angle A, if I subtract 120 from both sides, and I can show that step if we need, minus 120, minus 120. So therefore angle A is 60 degrees. Now if I know that this is 60 degrees, then I also form another straight line over here, and that also has to be 60 degrees. So you can see in that triangle, I've already got two angles out of that triangle. So in this blue triangle, I have an angle of 60 degrees plus 60 degrees plus angle B equals 180. That's the triangle rule. So 120 plus B equals 180. Subtract 120 on both sides. B will give me 60 degrees. And I'm done. I got my values for A, B, there's B, where did I write C, and D. And we got all our angles. So there's going to be a worksheet for you guys to practice these ideas. You're looking for regular polygons. You're going to take what is the measure of each interior angle, what is the measure of the entire angle, and go from there, and that will help you solve these problems.